This section asks us to find the inverse of each matrix if it exists, so that means it won't always work. First, we start off with 1 over the determinant. So 3 times negative 2 is negative 6, minus 4 times 2 is 8. So it will exist. It won't exist if we get a 0 there because division by 0 is not allowed. Okay, then we do our do-si-do, change signs. So we've got negative 1/14 times. Now, in the back of the textbook, they stopped there and did not distribute. On your test, they do. So if you check in the back of the book, I think you'll see this answer. But if you're doing one like this on the test, it'll look like that. So I'd rather you practice the way it's going to be on the test. Makes sense to me. Okay, so we're going to get 1 over the determinant. 7 times 8 is 56, minus 9 times 6 is 54. And then we have the do-si-do, change signs number. So 56 minus 54 is 2. And again, if you check in the solution manual, that's how they leave it. But we want to practice the way it'll be on the test, so let's distribute it through, and this is how I had you do it on the worksheet. Once again, 1 over the determinant, so 12 minus negative 12. And then we've got do-si-do, change signs, so positive 3, negative 4. So 1 over 24 times, and this is what they have in the back of the book, but we should distribute. Why leave stuff half done? And that'll be our final answer. So once again, we start out 1 over the determinant. So 6 times negative 1 is negative 6. Minus negative 6. Oh, Houston, we have a problem because 0 divided by 1 doesn't work. So this one does not have an inverse. Okay, here we go again. 1 over the determinant. Negative 4 times 0 is 0. Minus 5 times 2 is 10. Do-si-do. Change signs. So I've got negative 1/10. To distribute through. So negative times negative is a positive. And that one's done. Now this one's just plain silly because we can only do inverses of square matrices. In fact, the only ones we actually practiced were 2x2s. So, yeah. Okay, to solve by using inverse matrices, they already wrote the matrix equation for us. So I'm going to be lazy, as I was generally in the videos before, and leave the left side alone and just focus on the right where the action actually happens. So I need to do the inverse of the coefficient matrix. So I have 1 over 15 minus negative 2, and do-si-do, change signs, times our constant matrix, another C word. So I've got 1/17 to distribute through. That'll be fun. And when we multiply matrices, it goes row by column. So 3 times 16 is 48. Plus 2 times 10 is 20. Negative 1 times 16 is negative 16. Plus 5 times 10 is 50. So I've got 1/17 times 68 and 34, which happen to be multiples of 17. Who knew? So we get 4/2 for our column matrix, which translates into an ordered pair as 4/2. So we need to find the inverse of the coefficient matrix. So 1 over negative 8 minus 3, do-si-do, change signs, and times our constant matrix. So I've got -1/11 that I'll distribute through at the end. And when I multiply matrices, we go row by column. So we've got -18 plus -4 and -27 plus 16. So by happy circumstances here, we happen to get nice multiples of 11. So our column matrix is 2, 1, which translates into the ordered pair, 2, 1. I did one step as I wrote this down. I put the equation in standard form. So the original equation had the y in that first equation on the wrong side. I switched the y and the 8, making that -8. So now we're up to where we started on 46. We've got our matrix equation, so we're ready to do the inverse of the coefficient matrix. I've got 1 over -6 minus 4 times do-si-do, change signs, and my constants. I'm going to have a -1/10 to distribute through when I'm done, but that's not bad. So we go row by column. I've got -2 times -8, 16, plus 14, 32, minus 42. And happily, they're all going to be multiples of 10. So I've got 30 and -10, which leaves us with -3. And negative times negative is positive 1 for our column matrix, which translates into -3, 1 for our ordered pair. Our coefficient matrix, 3, -5, 4, 3, x, y, and -13, 2. So we need to do 1 over the determinant. 3 times 3 is 9, minus -20. Ooh, 29. Okay, our do-si-do doesn't look much different, but we can change signs, and times the constant matrix. Row by column, I've got -39 plus 10 and 52 plus 6. Hopefully they're multiples of 29. Okay, -29 and 58. Happily, I get -1 and 2. As an ordered pair, it's -1, 2.